Let's solve this vector motion problem step by step. We have two particles P and Q moving in a plane, and we need to determine if they ever collide. Let's first set up our coordinate system and visualize the initial conditions. Here's our XY plane. Particle P starts at the point 3, 5, and moves with a speed of 14.5 units per second in the direction of the vector negative 20I plus 21J. Let's solve part A, finding the velocity vector of P. First, we need to find the unit vector in this direction by dividing the direction vector by its magnitude. The magnitude is the square root of negative 20 squared plus 21 squared, which equals 29. Then we multiply this unit vector by the speed of 14.5 to get the velocity vector, which comes out to be negative 10I plus 10.5J. For part B, we need to find P's position vector at any time t. The position vector equals the initial position plus velocity times time. Plugging in our values, we get 3 minus 10t for the x component and 5 plus 10.5t for the y component. Now, let's look at particle Q. Q starts at the point negative 1, 3, and has velocity vector negative 5I plus 7.5j. For part C, we need to find the distance between P and Q at any time t. The vector from P to Q is Q's position minus P's position. After simplifying, we get 5t minus 4 for the x component and negative 2 minus 3t for the y component. The distance is the magnitude of this vector, which simplifies to the square root of 34t squared minus 28t plus 20. Finally, for part D, we need to prove that P and Q never collide. For a collision to occur, the distance between them must be 0 at some time. Setting our distance equation to 0 gives us this quadratic equation. The discriminant of this quadratic is negative 1936, which means there are no real solutions. Therefore, P and Q never collide.